All right, 8th graders, happy Tuesday. Um, Now it's time for a little bit of math notes. Today is February 4th, 2014, and this is going to be page 36 of your notes. And go ahead and title this page Graphing Equations. And what we're going to do is we're going to be giving you equations for you to graph, and you're going to tell us whether it's a linear equation where a line was formed, or if it's a nonlinear equation where solid line, straight line is not formed. So let's go ahead and copy down the definition for linear equations. And that is where every time x increases, y increases by the same amount. And the graph of the equation is a straight line. So go ahead and copy that down, and I'm going to set up a table here for us to graph. All right, so go ahead and copy down the information that you see below the definition for linear equations. We're going to work on the green problem first, and then we'll go over the blue problem. So the green problem gives you the x values, where x is going up by 1 each time, and y is going up by 5 each time. So because y is going up by the same value, by 5, each time that x goes up 1, this should form a straight line. So I'm going to find the first points of 1 and 3 and plot that point. Then I'm going to find 2 and 8, and I'm going to plot that point the best I can. And then I'm going to take the next point of 3 and 13 and plot that. And you will get a straight line when those points meet. The blue information, let's see. The x's are going up by 1. The y went up by 8, then it goes up by 16. So here we can see that the y's are not going up by the same value, so this should not form a straight line. And when we plot it, the 2 and the 1 would be there. 3 and the 9 going to be somewhere up there, and then the 4 and the 25 would be way up there, and that would actually not form a straight line. But as we go through these examples, it'll make more sense. All right, so the instructions going forward is to graph each equation on a coordinate plane and indicate whether the equation is linear or not. And here is the example problem that we're going to work on, so go ahead and copy that down. And then the steps for you to solve are listed, and we're going to copy those down as well. So you can go ahead and pause the video, copy all those steps down, information, and then I'm going to show you how to do this. All right, in order to solve, we're going to set up a table of solutions. So we're going to have our x column, and then the equation itself is x cubed minus 2, and then we need room for the y, and then our x and y values. And it says that the x values that we have to use are -2, -1, 0, 1, and 2. So when we're doing these, and you have to set up the table of solutions so that you can get your ordered pairs in order to graph, the x values that you use are always these 5, unless you're given other directions. So now we're going to take the -2, we're going to cube that, and -2, so that's -8, and -2, which is -10, that's your y value, which means that your x and y values for that are -2 and -10. All right, so if the next value for x is -1, that means we would have -1 being cubed, and then subtracting 2 from that. So that's going to be a -1 minus 2, which is -3. So then our points here are -1 and -3. All right. 0 cubed is 0, and so 0 cubed minus 2. That's going to give us a negative 2. So then our values here, our points are 0 and negative 2. Now we're going to plug in 1 for x. 1 cubed is 3. 3 minus 2. That gives us negative 1. Wait, whoa, 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 whoa. Yeah, negative 1. 1 minus 2 is negative 1. And then that means our points are 1 comma negative 1. And we have one more to do. 2 cubed, which is 8, minus 2 gives us 6. So then those points are going to be 2 comma 6. All right, and then all we have to do is set up a coordinate plane over here. Here's our x-axis, there's our y-axis. I'm going to make maybe 10 or so of these. All right, so the first point that I want to plot is the negative 2 comma negative 10. So I'm going to find negative 2 on the x, negative 10. It's going to be somewhere around there. Then the next point is going to be negative 1 comma negative 3, which should be around there. And then 0 comma negative 2 be somewhere around there. 1 comma negative 1 will be somewhere there. And then 2 comma 6 could be somewhere up there. And when we form these lines, we do not get a straight line. So the final answer that we want to say regarding this problem is that this is a non-linear. So we took an equation, we set up a table of solutions. We were then able to get 5 coordinate pairs to put on the graph to then see if it forms a line or not, because that's what linear is. In this case, it did not form one continuous straight line, so it is nonlinear. All right, we're going to do one more problem together, and then you're going to go ahead and do practice 2 on your own. All right, so I went ahead and set up a table of solutions, so that way we can get the coordinate points for that equation. I listed out, the negative 2, the negative 1, the 0, the 1, and the 2. I then use those for my x values, so now I can get the y values. So here for negative 2, when I plug that in, 2 times negative 2 is negative 4, plus 1 is negative 1. Then when I plug negative 1 in, I get negative 2 plus 3, which is 1. And then when I plug 0 in, I get 3. When I plug 1 in, I get 5. And when I plug 2 in, I get 7. So if you look, we can tell whether this is going to be linear or not just by whether the x's and the y's are going up the same. So the x's are all going up by 1. So from negative 2 to negative 1 is plus 1. From negative 1 to 0 is plus 1. From 0 to 1 is plus 1. From 1 to 2 is plus 1. So those are all going up plus 1. The y's, this one went up 2. This one went up 2. This one went up 2. And that one went up 2. So because the x's and the y's respectively went up the same amount each, we know that this will form a solid line. So let's go ahead and finish filling this in. So our x and y values are negative 2, negative 1. This would be negative 1, 1. This would be 0, comma 3, 1, comma 5, and then 2, comma 7. I'm going to set up a coordinate plane here. Hopefully yours will look better than mine is. And I'm just going to go a couple. All right, so the first point that we have to graph is negative 2, negative 1. So I find negative 2 on the x, which is right there. And then I go down to negative 1 on the y. So that point is there. Lionel, make sure you go to the piano room. All right. So we plotted this one. Now we got to do the -1, comma 1. So I find -1 on the x, then I go up 1 on the y, and that point is there. 0, comma 3 is there. 1, comma 5 is going to be there. And then 2, comma 7 is going to be there. And this does form a straight line. So we can say that it is linear. Yay! All right, let me shift this up a little bit so you can see the next practice problem that you have to do. Hopefully I don't mess this up. It's being slow. All right, I'm just gonna write it below. So practice 2 is y, come on. It's y equals -x squared. As soon as this unfreezes, I'll write it below so you can see. Oh, there we go. So y equals, no, wait for it. There it is. -x squared. And that is practice problem 2. So you have an equation. Oh, whoa, whoa, whoa. So you have your equation of y equals -x squared. Set up a table of solutions, just like we did in the previous 2 problems. For the values of x, you're going to use -2, -1, 0, 1, and 2. Find out the y's, find out the points, put them on the graph, tell us whether it's linear or not. All right, and if you made it through this far, I do want to leave you with a joke. So what is the quickest way for anyone to count cows? The quickest way for anyone to count cows. You stuck? Use a calculator. All right, see you guys.